In this lesson, we will learn about wireless LAN controller, ports, and interfaces, which will help us understand how network traffic flows in a wireless network that uses split MAC architecture. As you may know, in a wireless LAN controller, ports and interfaces are two different concepts and they are not interchangeable. Ports refer to physical properties of a wireless LAN controller, and interfaces are logical, which usually requires configuration, but they work together to handle network traffic in the split MAC architecture. Let's look at this wireless LAN controller. As you can see, it has a service port and a console port. Both service port and console port are used for out-of-band management, system recovery, and initial boot functions. From the diagram, the service port is connected to a switch port in access mode, which allows access the wireless LAN controller remotely via SSH or a web browser. On the other hand, console port provides an asynchronous connection to a terminal emulator, 9600 baud 8 data bits, one stop by default, which allows access to the wireless LAN controller locally, which means we have to be physically near the wireless LAN controller. The wireless LAN controller also has a redundancy port. The redundancy port is used to connect to a peer controller for high availability operation. For production deployment, always connect redundancy port to a switch, which allows the standby to detect if the active is up and running. In this network diagram, these two wireless LAN controllers are connected together via a crossover cable, which still allows us to configure this as the active and this as the standby. However, when this redundancy port is down, so this redundancy port is also down. If we put a switch in the middle like this, when this port is down, so this port is still up, and it allows the standby wireless LAN controller to detect the active wireless LAN controller is down, and it will take over and become the active. Wireless LAN controllers usually have multiple distribution system ports, which are used for the following access point traffic: couple-up tunnels, both control and data; management traffic using a web browser, SSH, SNMP, TFTP; and client data from wireless client to wire VLANs. As you can see, the distribution system ports must carry data from multiple VLANs. Therefore, these ports must operate in H02.1Q chunk mode. The switch ports that connect to the distribution system ports must be configured for unconditional H02.1Q chunk mode. Distribution system ports can operate independently. Each port transports multiple VLANs to a unique group of controller interfaces. The controller interfaces are logical, and we will learn more about them in the next slides. For resilences, you can configure distribution ports in redundant pairs. One port is primarily used. If it fails, a backup port is used. For resilences and high performance, distribution ports can be configured as link aggregation group or LAG, such that they are bundled together to act as ether channel or port channel on a switch. With LAG configuration, traffic can be load balanced across the individual ports. If one port fails, traffic will be redirected to the remaining working ports. To understand how the network traffic moves between wireless clients and cable clients, we also need to learn about the logical paths, the interfaces of a wireless LAN controller. The first interface is the management interface. It is assigned with an IP address which allows normal management traffic such as radius user authentication, wireless LAN controller to wireless LAN controller communication via a switch network, web-based and SSH sections, SNMP, network time protocol, NTP, syslog, and so on. The IP address on the management interface also allows to terminate couple-up control and data tunnels between the controller and the IP. In this diagram, the IP establishes two tunnels, control and data, to the wireless LAN controller on its management interface and terminated at this IP address. The next interface is the redundancies management interface. The redundancies management interface is used only in the high availability configuration. The redundancies management interface is assigned with an IP address that is used by the standby wireless LAN controller. The next interface is the virtual interface. The virtual interface is assigned with an IP address and only be used to communicate with wireless clients so that the clients can issue DHCP requests, which allows wireless LAN controller to relay the request to an actual DHCP server that provides IP addresses to the clients. It also allows the client to send web authentication information to a wireless LAN controller. All wireless LAN controllers in the same mobility group can be configured with the same virtual IP address, which allows the controllers appear to operate as a cluster as clients roam from controller to controller. The next interface is the dynamic interface. The dynamic interface is used to connect a VLAN to a wireless LAN. Each dynamic interface is assigned with a VLAN associated with a SSID on the IP so that it can handle the traffic from the IP. In this diagram, we want to configure the IP with two wireless networks. The first one is IT Life Skills Staff maps to VLAN 10, and the second one is IT Life Skills Guest maps to VLAN 20. In order to do that, we need to configure two dynamic interfaces on the wireless LAN controller and assign the interfaces to VLAN 10 and VLAN 20. The last interface is the service port interface. The service port interface bounds to the service port and used for our band management. The service port interface is the only interface that's mapped to the service port. All other interfaces map to distribution system ports. Let's now analyze the network traffic flow on this diagram. First, we need to configure the distribution system ports as a link aggregation group and make it a chunk port. As soon as the IP powers on, it will establish the two tunnels to the wireless LAN controller on the management interface and download the configurations from the wireless LAN controller via the control tunnel, which allows it to provide the wireless service. When the laptop connected to IT life skills staff, here is how it sends the data to server 10. First, the data packet gets sent to the wireless LAN controller via the CAPWAP data tunnel. As soon as the data packet reaches the management interface, the wireless LAN controller delivers it to the dynamic interface for VLAN 10. The data is encapsulated into an Ethernet frame tagged with VLAN 10 and then be forwarded to the chunk link to the switch, which delivers it to server 10, since server 10 is in the same VLAN. When the laptop connects to IT life skill guest, the similar network traffic flows from the laptop to server 20 like this. As you can see, the client data traffic between the IP and the wireless LAN controller is layer 2 independent, since they are terminated at layer 3 via the data tunnel.